All right, so I think we are live on YouTube to get started with the session. Just to confirm, Vinayak, could you confirm that we are live on YouTube?
Yes, we are live.
Great, awesome. So perfect. Then I think we can get started with the session. Right. Hi, everyone. A very good evening to all of you. This is Suraj, co-founder and CEO at Decibels Lab, and I'm also the course director who take care of a lot of activities that happens at Decibels Lab. And I would be the person who's behind, getting a lot of courses done to help engineers to pick up their skills in the new areas. So without much of the note on the person side or about the company side, we would like to get started with the session. Coming to the topic today, we are delivering the subject on certified bootcamp on electric vehicle powertrain, right? So let me give you a little bit of introduction about the session as well. So again, what is that you're going to learn in next couple of days across this session. So let me bring up the screen. Yes. So this bootcamp is basically a 3-day program, and that is happening and that is starting from today. That is 21st of July, and it is spread across the next 3 days. And it's, as I said, it's 3 days, and it's about hour and a half in each day, and then it is taught by all our teammates at Decibels Lab. And we would be delivering it through online mode, and also you will have hands-on sessions. That means you could be engaged in activities like hand calculations, and also working out on the details with Excel sheets and stuff like that in next days ahead. So why you should attend this session? So obviously the EV is a new thing. There are a lot of opportunities for engineers. We see there's a lot of people transitioning from gasoline systems and diesel system to electrification. We are providing a lot of training programs for upskilling at many industries. Also, there are a lot of opportunities for entry-level freshers across the industry, maybe at startups or also at established OEMs as well. So if you want to pursue your career in the areas of EV, so basically you should know something specifically about the direction. Maybe here you're just exploring that, okay, does it suits to you, or what is the technology in behind of EV in place? So that's why you could just participate in this session. Yes, you will get a certificate by participating in this course, but you have to be the part of all the 3-day live classes to get the certificate, and the certificate link will be shared at the day 3 by end of the session. So yeah, you have to be there to take the certificate if you want the certificate in place, or if you're not attending it, it will not be available for you. So cool. So coming to the technicalities of the course, so it's a 3-day program, as I was mentioning. We call this a module 1. That's day 1. It will be taken by me. I will talk about a lot of these things in the areas of EV vehicle architecture, components of EV, and it also talks about a bit of the technologies behind them, and a little bit of subsystems in detail as well. And tomorrow it will be taken by Mr. Krishna. So we'll be handling the session to help you to understand the component sizing. The component sizing is basically talking about sizing the motor, sizing the battery, torque values with respect to different requirements and stuff like that. It is a very, very small thing, that you could really pick it up, because as a sizing and simulation, it's like a huge and extensive amount of work somebody does. But if you are a person who just want to understand how do you get started, you can definitely get ahead with the Excel sheets and then build it. But if you're a professional in the industry, you possibly use MATLAB, you may use Altair, you may use toolboxes like Ricardo, GT Suite, and stuff like that. Okay. The next part is basically the day 3 that we talk about EV testing and data acquisition also. And that session will be taken by our teammate, Mr. Srinidhi. Cool. So that's the 3-day program. And as I said, there shouldn't be any cost for this program to enroll in. Good. So with that note, I think you are clear now that, okay, what is the topic that we're going to cover for today. and that's my session. So today I'll be talking about EV subsystems and technologies. So let's get started with the course itself. So on the very first note, everybody is behind electric vehicles today. It's government of India. I read the news about a few minutes back that there are 11 lakh vehicles has been registered in India which are electric in this financial year, just started about 3 months, nearly 3.5 months. It's a big growth, right? Compared to last year, I think we have achieved already the number of registrations might have crossed compared to last year. So it's everybody is just aligning themselves, and the whole global OEMs are shutting down their diesel engineering technologies, and then everybody is trying to move towards battery electric vehicle or fuel cell electric vehicles. This is a huge transition, the billions and billions of dollars, and a lot of people in the industry going to lose jobs, or they have to upskill themselves to find relevant jobs in the specific area. A lot of manufacturing sectors are going to shut down because nobody want crankshafts, nobody want engine heads, connecting rods, gut joint pins, piston rings, and all this stuff, right? So you don't have too many moving components. There's not much of requirements for vehicle servicing as well. It's going to create a huge impact on the ecosystem as a business itself when we try to move from diesel and gasoline system to electrification, right? So, but the major motive from everybody to move to electric is because we want to achieve lower emissions. You can call it sustainable mobility, but yeah, I would not say it's sustainable in sustainable way. But yeah, you could just say you want to reduce emissions, right? So that's the overall objective why we want to do electrifications for automotive industry. So, but can anyone just confirm, how many of you agree that electric vehicles are eco-friendly? You could just debate just for a couple of minutes to get started with the session. How many of you really justify that EV is eco-friendly? Don't you think there are a lot of problems with EVs as well? But why do you think that the whole world is moving towards electrification? We may have problems with batteries. We may have problems with rare earth materials like lithium or nickel. We may have problem with replacing the batteries that would cost. If you come across Tata Motors is telling about 7.2 lakhs. I mean, don't quote me if I said the price. So to replace the battery after the warranty, the cost is about Tata Nexon is about 7.2 lakhs, as I read from some of the articles. I mean, it's damn expensive, right? So you might have saved the money for this fuel, but later on, once you have to replace the battery, that's going to be very expensive, and you need to recycle those batteries. If you don't do the proper recycling, then it's going to create hazardous possibilities in the water resources, soil resources, and stuff like that. And at the end of the day, you have to charge this vehicle at some point by largely produced energy stations that runs on coal, and you just going to make emissions over there, not by making emissions at your vehicle. So with all these things, how do you justify EV is eco-friendly, right? I mean, I think if somebody would like to unmute and speak, I think you have an option to unmute as well. So I think we can hear from a couple of people. How do you guys justify EV is eco-friendly? Anyone? Because you would be spending a lot of time from today.
It reduces harmful oxides.
All right. Okay. Thank you. Anyone else? Why do you say? Yeah, please.
If you look at from the emission point of view, like in longer run, then it can be seen as a good option. While implementing this whole thing, there are problems, and it has its own cost involved in that. But over the time, if we look at the scenario, it will average out, especially the cost. So since it's a new technology coming into the place, so it is likely to have a higher cost. Apart from that, there are other attributes like batteries and the material for the batteries. So there it requires more research and other aspects. But if we look at from the emission side and looking at the global scenario about the global warming and the climate changes, it is a feasible solution, in my opinion. Thank you.
Fantastic. Good. By the way, good to hear that answer. Awesome. So now, okay, anybody? I think there's one more person named Tejas. Maybe he wanted to comment as well. Okay, we will give an opportunity to maybe only one person to take up the next option to unmute. So Tejas, you had anything to comment? Yeah. Go ahead, please. So maybe there's some audio issue at your side, so cool, no problem. Let's go ahead now. It's said that okay, there are some issues definitely today, but these issues will be solved is the answer. And on the long run, the cost is averaged out as another input to the discussions. And then disposing of the battery is a problem. We still have to work on new technology. The cost is going to reduce because it's a new technology, and over the days we can expect some reduced cost. There is also some answers I see in the chat box. Hybrids can be said as the perfect vehicle technology in 2022, as EV said as a future of mobility to attain sustainability. Great. So I think as I'm also like from the similar background, so I want to stress out on some things. Okay, so as we are guys with technical background, so we always try to prove things technically, right? And this has to be justified analytically. I'll just walk you through in the next 5 minutes on how EVs are eco-friendly, and they are eco-friendly even today as well. If you charge them with coal power plants, they are still eco-friendly. Okay, even today, the current vehicle that is running in the market. Okay, now let's try to compare how this is going to be compared with gasoline, how it is compared with diesel, and then how it is compared with electric. Okay, so let's take it ahead. When we do an analysis, right, so we need to think not only between the fuel station to the tank. We know that vehicle makes emission, petrol diesel vehicles makes emission when you drive it, but the electric may not do emissions anything here, right? In this region, you just pretty much have like zero emissions in this condition if it is an electric, right? But if it is an IC engine, you're going to make a lot of emissions here as well. Then you also need to know where does the journey go so far in actually extracting, getting that fuel. So you do an extraction of fuel, then you have transportation of fuel, then do a refining of fuel, then you do a transportation to a fueling station, and then you refill the petrol tanks in place, right? So you go through a lot of journey to basically bring that fuel into the tank, and then you burn it, then you create a energy out of it. So, but you need to just estimate the emissions from here to here, right? If you do emissions from that end to this end, it is called as a well to wheel analysis. Okay, but if you do analysis only between pump to wheel, that means you're just comparing apple to pineapple. You also have to do something like well to pump and all these things in place. So this is basically gives you an idea that how much EV is eco-friendly compared to an IC engine in place in the world, right? So now let's just go ahead and compare this and prove this technically right. Okay, so for that I've just done a comparison study between a few vehicles, right? So now let's just go and take a deeper look into the details in place. So yeah, this is some data that is there. Like again, we don't have any technical justification right now for this, but we have to prove it technically, right? So you see, this is a car, let's say a mid-sized car like a Maruti Swift, and if it drives about 12,000 miles, that's average about 18,000 kilometers. It makes about 11,000 lbs of pounds of carbon CO2 and about 6.5 lbs of NOx, and then about 0.4 lbs of the particulate matter. If you compare that with electric vehicle, okay, which is recharged by a mixed source of energy. That means you have a renewable and then you have a coal power plant, and then if you charge it, it makes a little lesser, right? So you see it's 11,000 and then it's about 4,000, right? It's a huge jump in reduced energy, even though you're recharging your vehicle with a mixed source of energy, right? It's not only coal, but it's coal, nuclear, wind, gas, and all the stuff. Then if you charge an EV with renewables, you just expect so much lesser emissions compared to EV. So what does this graph expresses? This graph expresses EVs are eco-friendly, even though you charge the batteries with a mixed source of energy. Even though if it is only coal, it would be a little higher than this, but it will be still emitting less compared to a gasoline vehicle. Then if you recharge the vehicle with renewables, that means you will have an amazing reduction in the emissions in place, right? So this is one important thing. So if you want to make achieve a higher amount of sustainability, then you can focus on recharging the vehicles with renewable energies. But the question is, when I said well-to-wheel analysis, how do you manufacture solar cells? How do you manufacture wind turbines, right? So you would make emissions in creating the wind turbines as well. You would make emissions in transporting the wind turbine. Once it is installed, it's going to come about like 10 to 20 years. Then after that, you need to basically dispose them. That creates emissions as well. So nothing is just so clean. It will have emissions, but people might have shown you like 0, 0, 0. It's impossible to achieve zero, because it cannot be just simply produced, right? So you need to utilize some of the form of energy to produce with Newton's laws. So there will be emission, but emissions a little lesser. You don't believe that it is zero. There is no meaning to tell that it is zero. It is stupidity, actually. If somebody tells it is zero, the EVs are going to make emissions, but it will have a considerable less emissions compared to a gasoline and a diesel. Okay, you can make it very, very less if you can actually recharge the vehicles with renewables. Great. So now let's get into a little bit of a math to prove analytically. So when we are discussing here, right? So it says, let's compare an apple to apple. Activa is a benchmark vehicle Ather has been developing upon. They wanted to meet Activa's performance, right? That was their replace the Activa with their vehicle in place in the mindset. So they want to achieve the same performance, and let's take them as an example today to discuss ourselves that they both are a similar sized performing vehicles. So if you take a range, that means if you put a 1 liter of fuel, ARAI certifies 50 kilometer per liter. It is not true, but let's believe that it is true. And Ather, if you charge once, this is an old vehicle, okay, Ather 450. And now it is 450X, and the generation, all these things in place. So you get about 75 kilometer per charge, right? And petrol's calorific value, let's just quickly roll through. I don't know, it's just not a big math, so we will just all understand. But a little bit of a logic is there, okay, to compare results in place. So the petrol calorific value is about 9528 watt hour per liter, okay? If you want to calculate average energy consumed at a wheel, right? Tank to wheel again, tank to wheel. Petrol's calorific value by range. That gives you 9528 by 50. That's basically these two numbers. You get about 950 watt hour per kilometer, right? That's what you consume to run 1 kilometer. But this is, as I said, tank to wheel. Now, if you want to calculate from the well to wheel, I have applied a very simple percentage value. But this percentage value has been taken out from some research papers and are credible documents so that you can trust this. Average refinement and transportation efficiency of a fuel is about 67%. That means you have about 33% losses. So when you divide that average energy at a wheel, basically this value, right? Let me just take a highlighter and and the color of this. Perfect. So this value and this value, if you put them together for the value here, so you get about 284.4 watt hour per kilometer. It means when you drive your Activa for a 1 kilometer average, you take about 284.4 watt hour per kilometer. Now compare same with Ather, right? So here range is about 75 It's about 2,400 watt hour is the battery pack size. So if you divide that 2,400 by 75, you're going to get 32 kilowatt hour per kilometer. Compare this with this. Wow, that's a big difference, right? Because 190 watt hour per kilometer to 32 watt hour per kilometer. There's a huge difference. Then charging and discharging efficiency is a very important thing. It means when you charge your phone, when you discharge your phone, even though you do not use everything, the battery will have some losses. It means it converts, when it is charging, an electrical energy to a chemical energy. And then it is discharging, it converts an chemical energy into an electrical energy, right? So in the process of this conversion, as I said, nothing is free, right? You need to use some amount of energy to convert to one form to another form. So you will have to lose something out. And that is basically in the form of a heat or some other form. So that is basically an average value is about 80%. And it is slightly lesser than this, but let's consider 80. It means it is 20% inefficient. So if you put the math here, you get about 40 watt hour per kilometer, correct? Then you have to also take a consideration of production and transportation. Why? Because this is tank to wheel. We need to calculate well to wheel. So it means from the production of electrical energy, it means extraction of coal. I have considered the requirements of coal here, that let's say we produce the electricity from coal. The production, it means from the well to the production of electricity to the transportation of electricity to your house. The value I have found is about, it is 30% efficient, it is 70% inefficient. It means it's very bad. And if an average energy with production and transmission losses, you put that equation, it's pretty simple and straightforward. You still get about 133 watt hour per kilometer. If you compare this value, right? If you compare this value with this value, it's largely indifference, right? So Ather consumes less energy to run 1 kilometer compared to Activa, right? So we all are in sync. And the next sheet talks about the same calculations, but for a different vehicles. Okay, here you can just see the Tata Nexon petrol, Tata Nexon electric, same segment vehicles, just a perfect match for each other to compare. You can easily see it's about 836, it's about 419. It's almost like 100% lesser in half compared to a petrol vehicle, right? Now, we need to use some basic logic here to figure out until now you only figured out energy consumption per kilometer, but not the emissions, right? And now I'm going to only do CO2. You can also do PM and NOx and all these things if you have values in place. You can get this data from very credible sources and stuff like that. Now let's understand. It means what exactly this line says is, if you want to produce a 1 kilowatt hour, you would make about 660 grams of CO2 if you use coal. Okay. Again, if you are to produce about 1 kilowatt hour, you will make about 530 grams of CO2 if you use fuel. Like fuel, I mean is gasoline. Okay. It's the data that is available statistically, so you can just refer that. You can also verify if you would like to verify it later on as well. Now, if you equate this, right, because to 1 kilowatt means it is taking 660 grams. Now you can equate your numbers. This is for Activa, this is for Ather, Tata Nexon petrol, Tata Nexon EV. So because it is 660 grams for a 1 kilowatt, for a 284, it means it's about a quarter kilowatt. So you take about 150 grams of carbon emission per kilometer. The same again, if you take for Ather, makes about 88 grams of carbon per kilometer. And then if you compare this and this, you get a straightforward answer. Now, I would like to open the floor for discussions. If you guys now believe, is EV eco-friendly? right? So can you understand that, like, how you could prove EV is eco-friendly? And it's pretty clear on the ground now that it is eco-friendly in place. Any questions from anyone? Floor is open for questions. Any questions from anyone to get a clarification? Okay, awesome. So it looks like it's pretty clear to everyone, I believe. So yeah, the answer is that EVs are eco-friendly. Can anybody now suggest me that how it can be more eco-friendly than what it is now? I said renewables is a way to recharge, so you can reduce emissions. Is any other way you can make EVs eco-friendly? Anyone?
We can increase the, we can reduce the charging time for the.
Yeah, I'm sorry. I'm sorry, I didn't quite follow you on the answer. So all right. So I see one answer in the chat box. Battery recycling can be advanced than what it is today. That's true. What else? Use lightweight composites for BAW and chassis. Great. Yeah, please. Sorry.
The charging time, we look at the charging time, we can reduce it, then that can also be a good thing.
Interesting. Okay, see, I mean, it may be a little contradictory on what you said, because not directly, but if I say, if you want to do fast charging, right, you would actually lose life of the battery, because fast charging will impact the life of the battery. It's not same as a mobile phones. Mobile phones, we use it like 1 year, 2 years, then we will just throw it away. We will buy a new different phone. But for the EVs, no, people expect like 5 years warranty, 7 years warranty, and all these things. So one way, if you make fast charging always, then you will definitely have some amount of loss of life for the battery. Okay.
Yes.
So this way it may not be very good. Okay, great. So then let's me just bring out some more things. Okay, I think, yeah, people are commenting and fantastic. It's really great and in-depth technical answers. On the very surface level, see, compared to IC engines, you need to go for a service every 10,000 kilometers, right? And if it is a bike, like depending upon the oil you put, synthetic, non-synthetic, and all these things, it's between like 2,000 kilometers and stuff like that. If it is a car, it's about 10,000 kilometers, right? So now imagine you don't have that kind of a servicing that you need, because very less number of components, less wear and tear, no replacement of oil required, all this stuff. That means you have reduced a lot of emissions that goes in manufacturing that oil, replacing the oil, again, that recleaning that oil, or refining that oil into a better shape and stuff like that. And in the way, you have saved a lot of emissions as well, right, compared to an electric, compared to a gasoline or diesel vehicle. Because there are less number of parts, there are less number of replacements as well. It means energy that has gone, energy, material, everything that is transportation that has gone into creating that part which were required to replace is also reduced. So by that way, you can actually do things. And if it is a regenerative braking, right, so because in the downhill you just let the engine on, and then you like press a brake, and you just let the engine on to do engine braking. But in the electric vehicles, you can just do a regenerative braking if you're going down the hill, correct? But that way you can recapture the energy. That is no possibility like that in IC engines, correct? And what else in place? Yeah, the batteries are problematic, but you can actually upsell the batteries. It means you can use the same battery for your home UPS applications. You can use it for toys and other stuff, and you can recycle the batteries. You can do a lot of stuff. It's just that it has to be done good than people just ignoring and throwing them out and here and there. Government has to create some proper incentives. If they return the battery, they get X amount of money. So obviously, then everybody would like to give the battery back. So all these things can be done. And then apart from this, the very important thing is the vehicle need to be designed properly. So it's just not like somebody buys things from China and let it to work in India, right? Or they need to properly do an engineering. It means to ensure that there's a lowest energy consumption at the wheel level by creating a rightly sized battery pack, rightly sized motor, if it requires transmission, performance of the vehicle. And at the end of the day, all of us are also responsible to drive the vehicle in the proper way. If you do any excessive accelerations, you consume too much of energy, you impact the battery life. So it's also required for us to involve a little bit here and there to make things work better. Great. And apart from this, there are a lot of other things how we can improve. But yeah, we just can let the debate be there as of now. Cool. So I think there are a few more people have commented using things like solar. Okay, we've discussed on that. And absolutely, Vivek, it's the right answer. Fuel cell electric vehicles can also become good alternative. Fuel cell, it takes some time. In India, we don't even call hydrogen as a fuel, right? It means it is not legal. Even you can use hydrogen in the vehicle. There's a lot of policy that has to come in, a lot of standards that has to come in. Production has to be standardized. Transportation of hydrogen has to be standardized. Storage of hydrogen has to be standardized. A lot of standards that are required with respect to making vehicles safer using hydrogen. It takes a while, maybe in India, to come into a picture. Awesome. So great, guys. I think that's good interactions in place. Thanks a lot, everybody, for barging in to the interesting interactions. Now, with all that questions in place, we can just move to the next one. Yeah. So just give me a minute here. I'll just grab a cup of water and get back to you. In the meantime, if you have it, you can just drop the questions in the chat box as well. Sorry, waiting. So now let's go to the next topics. That's basically the EV subsystems. All right. So what are the EV subsystems? I think most of you already know that EV consists an optional transmission. Transmission may be required, may not be required, depending upon the design requirements, right? Motor is obviously a required thing. Then you have an inverter. It is also called as a motor controller, right? Which take care of controlling motor speed, motor torque, motor modes, reverse, forward, city, speed, sport, all these things. Then we have a big battery pack that is here. Then we have a battery management system that takes care of the battery safety. We have an onboard charger, which takes care of charging the vehicle. We have a DC-DC converter, which is there for some reason. We will discuss down the line. Then apart from this, we also have an air conditioning system that is completely new compared to gasoline systems. Then we have other systems like battery heating or battery cooling as well. And the same way, the motor heating and a motor cooling as well. Then on the other side, you also think there is an option called quick charger, which is basically a fast charger. We will talk about all these things down the line in the further discussions. Now, let's get started with a few interesting topics. Again, let's open the floor for QA. And I would like to hear the comments from your side that hub motor and non-hub motor, right? How do you select between these two? What are the advantages and disadvantages of a hub motor compared to a non-hub motor? So any quick answers from anyone's here? Or like, how do you think the hub motors will be a problem? Will it be good? Any answers quickly? Right. So non-hub motor require restive parts. Good. That's a pretty simple one. Now let's get started. See, hub motors have a packaging constraints. So what is a packaging constraint? It means you do not have too much of space in the wheel. You have designed a wheel, then you need to put your motor within the wheel. So because of that, the diameter of the wheel and the width of the wheel both are constrained. And then on top of this, the weight of the wheel is also a constraint in a vehicle dynamic fashion. So width and the thickness is the two parameters. How do they impact? If you want to achieve motor torque, right? If you want to achieve motor torque, you need to have a lot of flux. So the flux, if you want to achieve, the motor has to be slightly wider, right? It means the surface where the magnets are there, it needs to be a little larger. It means if you take a consideration like this, a difference between the motor of the same technology, let's say you can't compare axial flux to a BLDC or a PMSM, okay? The way of arrangements of motors are different. But if you take a BLDC motor of this size and another BLDC motor of this size, right? Like this is a width and this is also a width of the motor or a length of the motor, let's take it like that. And they both have a same width or a diameter in case. So this motor can produce larger torque compared to this motor. Why? Because it is having more magnetic surface, right? It means there is a more flux available and at the magnetic side. If you also have been able to produce more flux at the coil side, then you can achieve a higher torque, right? So the width of the tire will help, the motor will help you in achieving the better torque characteristics. If you use a motor of this size, it is also good for a specific application. It doesn't mean it is bad. But if you want to achieve better performance, higher torque, you have to go for a non-hub motor configuration. You see the motor here, it may not be having a larger diameter, but it is having a more length. Okay. So by this way, the motor's first requirement is if you have a large higher torque requirements, then you cannot go for a hub motor configurations, right? But the other thing is the non-hub motor, if you need to put a belt drive or a chain drive, blah, blah, all this stuff, or a transmissions in between. That's another problem of the non-hub motor. But a hub motor can be just put inside the wheel itself. It becomes so simple to achieve the packaging requirements. So you don't have to find about where is the mounting, does it fit properly, does it align properly, does your belt system work properly, does your gear system work properly. So there is no headache like that, right? It is just so pretty simple, right? So that it just works so good. But other problem is, if you have this is regarding the dimensions, okay? You cannot increase the diameter as well because the wheel sizes are limited. If you go to take a scooty, the size of the wheel is limited. If you take a bike also, there will be a limited size of the diameter, also the width. I think it's clear for everyone, right? The second thing is the weight. If you have the weight in the wheel, it creates the problem in terms of vehicle dynamics. If you put a motor inside a wheel, then you're increasing the weight of the wheel. The weight of the wheel, what happens if you imagine if you hit a pothole or a bump, right? Then the complete load on the vehicle will be on the tires, right? And then if you have a scenario where you have to hit a bump and then because of the bounce back, right? There's a larger amount of inertia in the wheel because the motor is also there. It will take more time to settle down. Okay, then it will create a problem for a vehicle dynamics. It means your vehicle will not be in a very good handling conditions. So putting a lot of weight on the motor, weight on the wheel is a bad thing. So there are some constraints like this. So people will go for a non-hub motor configurations. Comparison of hub and a non-hub motor. So any questions from anyone till now? Anyone have any questions? Okay, so no questions as of now. So then let's move ahead. If you take again two technologies in place, both are advantageous, both are also having their own limitations. Now let's move on to the the requirement of transmission. The transmission is a very interesting topic. Now let me bring that out with some interesting discussions. Okay, I would like to know from your side that why do you require a transmission in the vehicle? So I will open the floor again for against for answers. So your involvement is very important. If you show more interest, I can also engage the session in a more better manner. Why do you think you require a transmission? Awesome. So there's one answer here. Okay, better torque control. Great. That's a very close by answer. Now, anybody, why do you require a transmission? All right, so I am expecting some quick answers. Let's go ahead. I think we have a lot of topics to cover. To reduce wear and tear, interesting. Okay, so I want you to draw some stuff. Okay, I will try to exit my presentation mode and then insert a link here on empty page. Cool. Now let's go ahead and discuss quickly. Why do you guys think we require a transmission? Okay, perfect. So as far as transfer, so as to transfer power to serve adjustable speed requirements, great. Before that, you need to understand a little bit of a vehicle dynamics. Okay, now let's go and do that. So do you know what is the torque characteristic for the vehicle? What is the torque characteristic for the IC engine? What is the torque characteristic for a electric motor? Okay, now the bottom line is basically this is let's say RPM, and then this is torque. The y-axis is torque, okay, the x-axis is RPM. Now I want everybody, if you can involve in a good way, that it would be really great. I would like you to let me know that how does the torque characteristics for the vehicle will be. Okay, so if we get started, right, so the torque characteristics for the motor, sorry, for the vehicle will be like this. Okay, initially when you start your vehicle, like a bike or a truck or a bus, it requires a lot of torque, right? That's why you put it in the first gear. Or imagine if you're a bicycle, if you have a bicycle, you require more torque in the beginning to push that vehicle to certain momentum, right? Then if you have a flat road, imagine this condition which you're discussing is in the flat road. The road is flat. You require a lot of torque. So you require a lot of energy to push the vehicle. So because you need to attain the momentum, right? So it means the torque required is little higher and your RPM is little lower, and then the torque will gradually reduce, and then the vehicle speed will increase, right? This is a typical torque characteristics of a vehicle. Understood? So now let's go and write a typical torque characteristics for the engine, right? You might have studied this in your college days. The torque characteristic of the engine goes something like this. The torque goes to a highest peak point, then it drops down. So, but see, the requirement in the vehicle is like this, right? The vehicle wants this thing, but the engine is giving this. So, but the vehicle and the engine will not match each other. Okay, they will not match each other. The torque output of the engine is not required as the motor, sorry, as the vehicle. But now if you compare that same with electric motor, the typical torque characteristics of the electric motor is like this. The electric motor can give you the highest torque in the beginning, and then slowly the torque reduces. I think everybody is in sync with this, right? No, you need to come back and justify here that if you require do you require a transmission or you do not require a transmission. So that's why we use transmission in IC engine vehicles, right? Which is basically this color. This is an IC engine vehicle. So here what we do is, if we want to attain, now let's draw it in red color. Sorry. Yeah. So this is your vehicle tractive requirements, right? But this is your engine output. Now, if you want to match the tractive requirements, you need to use a lot of gear ratios. First gear, second gear, third gear, fourth gear, fifth gear, something like this. Okay. So that is why you use multiple number of gear ratios, so that you will be able to pull the torque from the compensation of RPMs and stuff like that. The first gear is highly torqueier than the last gear, right? It may be a overdrive as well. That's why you need a lot of transmission sizes in a lot of many gear ratios in IC engines. But if you take the same with electric motor, right? If I overlap or torque characteristics, the vehicle torque requirement is something like this, right? Almost. The motor torque characteristics are almost aligning to the requirement of a vehicle torque. By that way, you do not really require a lot of transmission. Okay, I mean higher. Okay. Okay, so you do not require a big transmission in if it is a motor, because the torque characteristics of the motor matches the torque characteristics of the vehicle. This way, you can actually develop a vehicle with a hub motor configuration even without using a transmission. All right. But if you take a requirement that if you want to, like, let's say the motor of this size is there, but it is having a better RPM, you can actually size the motor in a way by using a transmission as well. Okay. Because the motor is happier to spin higher than actually to consume more, produce more torque. By that way, you can compensate between torque and RPM figures in place. All right. So by this way, the motor is more suitable for a tractive application than an IC engine. That's why you may not require that many number of transmission gear ratios in motor compared to an IC engine. But hence, you do require transmission in a cases where if you want to alter your component sizing, or if you want to have a better performance, all this stuff in place. But it is optional. Great. So any questions from anyone?
Hello, sir.
Yeah, hello.
So as you say that we get initially high torque in case of EV. Sir, in the initially, if the some system is in stable condition and it will suddenly increases load, then will it not be affect its efficiency or any other parameter like generate more amount of heat?
I'm sorry. I heard that you say that if there is a higher load, and what is the condition?
No, sir. Actually, in case of EV, as we say that we get high torque at in starting phase also. So, if the system is in stable, or yeah, we can say that if the system is stable and suddenly we put such high amount of load on it, so I think it will affect its efficiency or other parameter like generate high
Right,
amount of heat.
right, right. You're absolutely right. So to go back to the the answer, it is like this. Okay, let's go back to the last slide, and then yeah. Now let's erase a little bit here. So now let me draw a characteristic curve for the motor. May I know which department the background you're from? Electrical?
No, sir. From mechanical.
From mechanical. Okay. Or else I'll share you the other document as well. Give me a second. I'll just show you how it looks like.
Sure, sir.
Okay. Just a second. I just want to show you some document that it becomes pretty clear for you that how exactly it is taken. And there is a specific torque characteristic graphs that I just thought to show that it be pretty clear for you. Right. So I think you can see the screen, right, which is visible here right now. So what exactly this says is the motor has a typical characteristics like this. It is having a constant torque region. It is having an intermittent region. The meaning of this is the motor, the same motor of a same size can give you a higher torque in some sort of short duration. Okay. When I mean as a short duration, it is like this. Maybe for 10 seconds, the motor can give you a lot of torque. It is not a continuous one, but it can give a higher amount of torque. We call this a peak torque, right? And there's a nominal torque. Nominal torque means it's a continuously, it can give some specific desired defined amount of torque. And it can also give you a, peak torque for a specific amount of duration. All right. This is a difference. This is a nominal torque. This is a peak torque. Typically what happens when you start your vehicle, right? It's only for like beginning 3, 4, 5 seconds. You need a lot of torque. So what happens is, yes, motor will be a little inefficient during that time, but it still provides you a torque in a way that your vehicle can move. It may be a little inefficient, but it is capable of providing that output. That is why it is, possible for a motor to be give a higher torque at a lower speeds for a short duration, and then you can bring it to a constant or a rated torque regions in place. Is that clear?
Yes, sir.
Yeah, it would not impact. Yeah, it will have a lower efficiency, but it's okay. You can you just have to compensate that with a duration in place. Cool. So now let me just go back and share my screen on the presentation. Okay. Anybody else have any questions? Okay. So now let's move to the motor side of it. So the motor controller is basically a power electronics and also an embedded systems. It contains a lot of electronics. The fundamental function of motor controller is you get DC from the battery and you have to give AC to the motor, because a lot of motors that are used in EV applications are basically the AC motors. So you take DC and you have to give output as a AC. So that means that involves a lot of power electronics. The second important thing which is there is you need to control the way you provide or the amount of torque, the amount of current, the voltage that you provide to the motor. So that means you have to basically ensure that there is a desired amount of voltage and a desired amount of current that is going into the motor with respect to the throttle input or with respect to the load demands on the motor vehicle in place. So that is what is basically the motor controller contains. It is a lot of electronics and control algorithms. And obviously, apart from it, you can have regenerative mode, braking mode, hill assist, downhill assist, uphill assist, or downhill assist, sports mode, eco mode, fan control, thermal behavior controls, and all this stuff, and diagnostics. A lot of these things are also taken care by motor controllers as well. Then the next part of it we'll talk about. I'll little rush out the content because I think I am about a few minutes behind. So again, if you take about batteries, we get different type of formats of batteries. You get cylindrical cells, you get coin cells, you get prismatic cells, then you get pouch cells. This is what Samsung, LG, Panasonic makes, right? They only make cells. So you need to basically buy the cells and build a module or a battery pack. So the battery pack is basically a combination of multiple cells. Sorry, module is combination of multiple cells. Battery pack is combination of multiple modules in place. Then all of this requires some mechanical integrity and also thermal integrity. It means you need to properly put in a right structure that when you hit a bump, it should not bend. The battery pack should be very stable in its condition. In the same way, the thermal management system also has to be ensured for the proper safety of the batteries as well. There are multiple chemistries that are available for the electric batteries. So we have different chemistries like lithium cobalt oxide, LCO, lithium manganese oxide, LMO, NCA, nickel cobalt aluminum, nickel manganese cobalt, lithium ferrous phosphate. Typically, these are the cathode materials that are used in the today's technologies. There are also anode materials, which you see here. Largely, we use graphite. There are also a lot of research going on for the silicon. Then you also see lithium titanium oxide, LTOs, are also coming in the market. So largely today, graphite and LTO are already present, but people are definitely working on various other areas as well for the anode materials. So now there is one question: what does 444 indicate module of battery in the last slide? Okay, okay. It's basically, you should not mention as batteries. That should be cells. Okay, it's combination, like it's possibly the number of cells that is going into the module. Because if you see it finally, there are 16 modules, maybe 444 into 16. That should be the summarized value, right? Let's just calculate that. 444 into 16 modules. Yeah, you multiply 444 and 16, you get about 7104. It means it's 7444 cells. Okay, and then that will form a one module. There are 16 modules like that. That will form a 7104 cells. I think the word battery is basically incorrect. We should use cells. Sorry, I took it from some internet source and it is not accurate. Yeah. Now let's go to the next thing. See, as you see here, that the cell is a little dangerous. Okay, the why is it? You all know that anything that stores energy is dangerous. Like you take electricity, so that is just carrying out a source, and then obviously it will contain. It will be a little dangerous for you as well. Okay, the same way here also. If you have a scenario where you have a energy storage device like this, maybe it's like nuclear, or it could be a dam or anything like that. So anywhere you store like energy, obviously it will have a potential hazardous. So the same way, the lithium ion cells are a little dangerous, definitely dangerous if you don't handle them well. But they have a very typical characteristic curve, so you need to be maintained. It is like this, okay? The lithium ion cells have something called the over voltage and the under voltage. These are some basic things, okay? Over voltage. So it means you cannot charge the battery above a specific limit. Okay, if you charge it above a specific limit, it can become too hot. It can do a gassing, and then that would create a pressure, and that would let the cells to rupture, and then rupture of materials can lead to a diffusion of anode and cathode, and then that would lead to a fire, and then you have a bomb. And then that's dangerous, right? So you always have to ensure that the cell doesn't go above a specific defined limit. As I said, each of the cell chemistries have different limits. Okay, if you take LFP, the peak voltage is about 3.8. If nominally is about 3.6, and under voltage cutoff is a little less than that. If you take an NCA or NMC is about 4.2. The under voltage is about 2.8. You have a larger bandwidth for operation. The same way here, all the cells have different over voltage limits, under voltage limits, over temperature limits, under temperature limits, and over current limits. Largely, these are very basic functions that a BMS should ensure that it has to be, maintaining the battery or a cells within the specific bandwidth. Okay, if you do not maintain, then you will create a problem for the battery's life or a battery's fire. So you need to ensure that there is something that takes care of these scenarios. So for that, we have a system like this. Okay, which is called battery management system. So you have units that measures the voltage of the cell. You have a device like this that measures the current of the cell, current of the battery pack. If the current drawn is more than a specific value, then the BMS will shut down the battery or disconnect the battery from the load. If the temperature goes above a specific limit or below a specific limit, the BMS will cut the battery from the load. Okay. And if the cells are going above a specific charge voltage, then it will disconnect the charger. If the cells are going below a specific voltage value, then it will disconnect the load. By this way, the disconnecting, imagine it's like a switch, okay? But it's an electronic switch. That's what our BMS does, okay? And the chargers, there are like a lot of technologies of chargers available, but let's not go too much in depth into it because the session will not be very much going that topics as of now. So here we have, the various different levels of charging. I just want to convey that and then move on to the next topic. That is basically level 1, level 2, and level 3. Okay, what exactly this means? So it means the amount of the current that you can draw, or let's say in together amount of power that you can take it out. Okay, so it's basically, if you take level 1, this is there in US. Okay, we don't have this in India because we don't have 120 volt architecture in India. We have like 210, 220 volt architecture in per hour grids. So the small socket can give you about 5 amps, okay, 20 volts. The larger socket, like an AC socket, can give you about 16 amps, right? So it means 220 into 16 would be getting about 3.2, okay? It's about 3.2 kilowatt, nearly, right? So that is from the big socket. If you take a small one, it means it's just about, 5 amps at max. So 220 into 5 would fall about 1.2 kilowatt, right? So 1.2, 1.4 kilowatt. It means the available output from the socket itself is limited. Okay, that is the way the levels are defined. I believe you're able to follow me and gain the direction on the content as of now. If you want to charge your vehicle faster, you have to install the larger capability in the grid, or you may have to take a multiple phases from the grid in place. So it means you should have a higher power availability. So what exactly the charger contains? The charger is again a power electronics. You have AC, that is from the grid. You need to convert that AC to DC. Okay. So first is the functionality, converting an AC to a DC. Then the battery requires a specific charging profile, like CCCV, constant current and a constant voltage charging. So you need to regulate the amount of voltage and the current that goes into the cell. By doing that, the functionality of a charger is satisfied. So this is power electronics and also control of power electronics. Again, we have a different type of chargers, slow chargers and fast chargers. The fast chargers are the one which we call as the DC chargers, which means that the whole conversion in this one as an onboard charger, it is there inside the car. Okay, the half-board chargers are the one which is where the battery, the charger module is outside the car. Okay, it means all the conversion happens outside. Directly you supply DC. Okay, you only supply DC. That's why you just have 2 pins. But in slow charging, you supply AC. This converts that AC to DC, and then this will be inside the car. Okay, that's the only difference. This is inside the car. These components are outside the car. Okay, they will directly supply DC to the vehicle to get charged. The advantage is DC chargers will be up to like 200 kilowatt as well. If you imagine if it's a bus, okay, the battery pack will be about 200 to 250 kilowatt. Imagine 200 to 250 kilowatt. If you want to charge that by a normal socket in our house, that would take about 10 days to 12 days. But you can't do that, right? So that's why you have a fast chargers where you could just charge them in 1 or 2 hours or 3 hours in place. Then you have some more components such as auxiliary components. Like if you take a vehicle and it is having a HVAC system, that means heating and cooling, right? How do you do heating? How do you do heating, cooling? So you need to have a compressor. You might have studied refrigeration cycle in your college days, right? ADD, advanced basic thermodynamics and advanced thermodynamics. There's a different system that takes care of heating the cabin and cooling the cabin. Let's take cooling. Cooling was done largely because of compressor. Okay. Now compressor was driven by an engine. Now there is no engine. You can't run the compressor. For that, you need to have a different motor to run the compressor. Okay. That means there is a motor to run the compressor. The motor also requires energy. That energy comes from the battery. If you turn on the AC, that means you're consuming battery as well. That becomes a load here, right? In the terms of heating also, the engine used to have a hot coolant that is used as a source of heating the cabin, but you don't have that now. So that's why you need to have a separate electrical heaters that is again consuming the energy from the battery to even heat the cabin as well. You have DC-DC converter because all your headlamps, tail lamps, and everything works at 12 volts. Okay, but the vehicle battery pack is about 48 volt, 100 volt, 200 volt, and things like that. Even bus has 800 volt. You need to convert the 800 volt to 12 volt to 24 volts, depending upon the commercial or a passenger vehicle. That's why you need a DC-DC converter. You also require battery heater. You require conditions like this. You need to heat the battery. The condition like warm temperatures, you require a battery to cool it down. Like this, the vehicle consists of a lot of components that is completely different, completely new in comparison to a combustion or a IC engine vehicle. That's pretty much what I wanted to cover, as a part of the today's session, just to give you an idea on what is a vehicle like an EV and what are the components that comes as a part of the whole electric vehicle. Now, if you have any questions at this stage, the floor is open for queries. What was the cause of fire in EV in India? Okay, so that's a very detailed possibilities to that to happen. Okay, I really do not know that why it has happened. I don't want to comment because I really don't know why it has happened. There are hundreds and thousands of reasons. That itself is a one research. Why the the fire can happen, what has happened, all these things. It's a very, very complicated thing. I may not be able to answer just in 2 lines because I might have not done a huge amount of research to kind of give you a right direction. Yes, if you ask me, that is true. The fast charging does reduce the life of the battery, no doubt on that. Is there an automatic charging cutoff in EV after it reaches the limit? Absolutely, Saurav. There is a system that is basically BMS, which takes care of disconnecting the battery. Okay. So now I believe you found this course interesting, right? So what I have done is I have delivered a very small portion of the course that we have created as a dedicated courses at Decibels Lab. Okay. We have a course here that would be available if you are interested to learn the fundamentals of course to a really good level. Okay. So this is an interesting course. This is about 10 hours of topic where I will be covering all the details of this course, which I've delivered today in a more in-depth way. Imagine I've done about 1 hours of content today, right? This course is somewhere about 10 hours. It just talks about all the components, technologies, subsystems in a really, really detailed manner so that you will be able to get a complete idea of EV subsystems. Okay. If you are interested to learn in continuation to today as a topic, so this is a course for you to get started. Our team will send you a coupon code if you're interested to take part in this course and learn something more from this course as well. So here we have done a very detailed understanding of battery, different compositions of batteries, different chemical components that comes as a part of the battery, what materials are exactly used, how is the construction of the battery, if it's cylindrical, if it's a prismatic, if it's a pouch, and explaining all the components more in depth and detail. As I said, it's about 10 hours. As of today, I've delivered about an hour of lecture, so you can learn more in depth through the program as well. You will get the notification from our team if you're interested to enroll for this course as well. How can we increase the life of the battery? Oh yeah, So there are many different ways how you can improve the life of the battery. Keep it within the good temperature bandwidth. Keep it within the good operating limits of current. Keep it is within the proper safety limits of voltage. Do not abuse the battery, or even if you drop a battery or a cell as well, it would have a impact on its life. And in a way, ensure that it is always secured with the battery management system, proper one, so that it is protected. So if you have all these things, you can, by doing many things like properly designing a charging system, properly designing the algorithm to extract best out of the battery, your measuring equipment on the sensors and other things. There's a lot of things you can basically use to make the battery go for a longer distance. It just depends upon what you want to achieve at this stage, but there are different ways how you can do things in place.